So let's start by focusing on this positively charged particle. So for this positively charged particle, we know there are two forces acting on it. There's this horizontal force pulling it towards the negative charge, and there's this vertical force pulling it along the electric field. And we know that when we add these two vectors together, we get a net force vector that makes this angle θ1 with the horizontal. And using our knowledge of trigonometry, we can conclude that the tangent of this angle θ1 must be equal to the force caused by the electric field divided by the force pulling the positive charge towards the negative charge. And it turns out I can write a similar equation for the negatively charged particle. So now I'm going to take these two equations and divide this equation by this equation. And doing that division, I get this equation here. Now, in order to clean things up a bit here, we need to make one key observation. We know from Newton's third law that when this positive charge pulls on this negative charge, that the negative charge pulls back on the positive charge with an identical force. This means that these horizontal forces must be exactly the same. So we can actually cancel out these two force terms here. This gives us that the ratio of the tangents between the two angles is equal to the ratio between the forces the two particles feel from the electric field. And we can always write the forces particles feel from an electric field as just the electric field strength times the charge on those particles. And we see here that the electric field strength will cancel, leaving just the ratio of the two charges. This means that the ratio of the charges on the two particles is exactly equal to the ratio of the tangents of the angles that the net force vectors make with the horizontal. That's pretty cool. And plugging in my known values for these angles here, I can calculate the ratio of these two tangents, and this gives me that the ratio between these two charges is about equal to 9. If you're able to get this, great work.